Okay, so we have output our character, and I'm just going to demonstrate the data that the output node generates for you when you've used procedural anatomy to set up your character. So the first output here is our model or skin. It's the entirety of the model, so you will be able to see if you put down a blast node that you have a character component, which is the body, the bone, the muscle, and we can, for instance, just choose the body, and it is the original model that you had in the input section. Now, if we unpack that, we're just using packing as a simple way to organize, and you get your model back and whatever attributes were on there. Now, we can change that and just delete that one. So we get the model of the muscles and skeleton. You know, if we just change that to bone, we get the skin or just that. Now, with that out of the way, we can show you the rest skeleton, and we'll just put a null down here to visualize it. And the rest skeleton is the entirety of the skeleton, all the bones in an animation skeleton that would be required for animating all of these bones, including accurate patella, any kind of hand bones, anything like that, radius and ulna. That is the entirety of the skeleton. You can see the points there. Now, if we switch between these two, this is the simple skeleton, and the difference between these two is marginal. We've just removed some stuff that you don't need. The reason for this is because we want to be able to transfer between the simple skeleton and the rest skeleton that you'll actually use for animating the character. This will match whatever animation you put into it better than with this, because generally there's no way to automatically animate extra bones, but we do have a process for that that we'll come to later. Now, if we go to the muscle simulation geometry, this is the actual simulation tetrahedral meshes, and you can kind of zoom in and see that we've triangulated that, but more than that, if we put the points back on here, you can see that now the points, it's filled with extra points inside the mesh that you need for tetrahedralizing and doing tetrahedral simulations. And that's optimized. It's not perfect. You can control that in the muscle node. One thing to note is we do actually include a lot of extra attributes and things like that, mainly to help with the simulation on the TET meshes. For instance, we have the usual directional kind of vector attributes that affect the way that the muscles flex, the direction that they flex in, if you will, and they form fit nicely to the body. Those are controllable, of course, but they are set up and should work out of the box for you. The next thing to consider as well is the collision of the character's arms and legs and things like that. Now, this works best on the muscles so far, and is a work in progress on the skin itself, but the body, and you can see it here, is colored in multiple colors, different to each zone of the body, basically. And these are just what are called collision groups, and essentially they're only going to collide with muscles that are in their own collision group right now. And this is to, stop common problems of like animation intersecting hands and bodies and things like that, and making sure that they can only collide with things that would be considered valuable collisions, which are self collisions between the muscles, basically. And the reason for this is just to optimize as much as possible the simulation before we even get to starting the sim. The muscle lines, and this one's good to visualize because these are lines that are automatically generated with your muscles and character. They match the origins and insertions, and will match the movement in the simulation rig. And then finally, the tetrahedral skin mesh of your character as well too. So same thing, we zoom in here. You can see if we turn that off, the points have been added inside the character, and that is for simulating the resulting skin.